sine pi over x is bounded. We know that. Bounded from bounded from below and bounded from above. By what?
And 1 and -1.
Perfect, indeed. So I have this piece. I built this piece in here. All I have to do is multiply all three sides by this quantity, as long as this quantity is not 0 and it's positive. This is sufficient. There is no need to write that. If I write this, it's sufficient. It includes this. It is. Because remember, x approaches 0 means x does not equal 0. And since it's a square root, will always be a positive number. So we multiply all three sides by the square root of x cubed plus x squared. So the left-hand side is negative the square root of x cubed plus x squared. The middle part is the square root of x cubed plus x squared times sine pi over x. And this is what I want. I want to have this function in the middle. And less than or equal to the square root of x cubed plus x squared. So this is the first hypothesis of the squeeze theorem. What am I trying to say here? Yes, it's squeezed. It's squeezed between two functions. This one from above and this one from below. So this is function, if you want, f of x, and this is function g of x. And this is, the whole thing is h of x. So that's the first hypothesis. The second hypothesis says, find these limits. If they both exist, as x approaches 0, of course, if they both exist and they are the same, then we conclude about h of x. So, number 2, limit of negative the square root of x cubed plus x squared as x approaches 0, and the other one, limit as x approaches 0 from the square root of x cubed plus x squared. Do these limits exist? Are they the same? Can anyone give us the answer, please?
Wouldn't it just be 0?
Yes. They both exist, they both are 0. From 1 and 2. By the squeeze theorem, what do we conclude about the limit as x approaches 0 from either side of the square root of x cubed plus x squared times sine pi over x? What do we conclude? It must be 0, because if it's squeezed between two functions and the limit of this is 0 and the limit of this is 0, obviously the limit of the function that we are interested in must be 0 as well. Okay, perfect. Questions? Limits on page 137. So these are the infinite limits. Oh, one other limit that I would like to work on, just in case, let's say the limit as x approaches 3 from the left, from 4x minus 1 over x plus, I'm sorry, I meant to write x minus 3. So let's work on this for 1 minute. And please enter the answer in discussion too. 1 minute. This should be 30 seconds. I did not put a time limit on discussion too. And in the meantime, I will get the book to what we want to, which is 2.6.
Does not exist.
So just put it in discussion too.
This is under test 1, review discussion 2, right?
Review discussion 2, yes.
Okay, thank you.
Thank you. Still in modules. It would not pop up because I didn't put a time frame on it. Okay, do we need more time?
1 moment, please.
Okay, 1 minute, please. Okay, finished? Okay, I'm looking at 807. Okay, so I saw correct and incorrect answers. So the first thing we do, we plug it in. 12 minus 1 is 11 over 0. We know that this is no hope, and we know that we have 3 possibilities, either infinity or negative infinity or DNE. We cannot jump into conclusions, right? We have to take it easy. The numerator stays positive, but 3 from the left means 2.9. 2.9 minus 3 is negative. I cannot write DNE. If it were from either side, I would have had to calculate both, and it would have ended up DNE. But it's not from either side. It's from the left. So positive over negative would be negative infinity. If I had limit as x approaches 3 from 4x minus 1 over x minus 3, I would have had to calculate both. One of them is negative infinity. The other one, 3 from the right, is positive infinity. Therefore, here I have to write DNE, but it's specifically from either side. If it's from one side, if you remember, we talked about this, but we have to repeat. That's why we review. We have to repeat and repeat and repeat and repeat. It doesn't come easy, right? So if it's from the left, chances are, or from the right, chances are that it's not going to be DNE. If it's from either side, there are chances that it will be DNE. Unless I have something like this squared, and then positive over positive will be positive infinity or something. So please always look at this. If it's not from either side, Think in terms of positive or negative infinity, not jump into conclusion to say D and E, because it's from one side. Okay, enough of that. Now 137, which 137 is, where are you guys? Okay, I see you now. So 137 is this, and I wanted to start with 7. Why I wanted to start with 7? I don't know. Ah, the gibberish. So that's why that's the first on my agenda. Okay, I chose 7, but we can choose anything else. I remember we did a problem like this. This is very important for many reasons. Number 1, the table. Because that table will come back in chapter 4. It will be a major issue. Major issue. So that's why this is important. So which one? I said 7, but we can switch to anything else. Is 7 okay? Did we do 7? I don't remember.
I'm pretty sure we did 8 last time.
Okay, so then let's do 7. Is it okay? 7 okay? Okay, so I have to copy limit of f of x as x approaches 0 is infinity. Limit of f of x as x approaches 3 from the left is negative infinity. Limit as x approaches 3 from the right of f of x is infinity. Limit of f of x as x approaches negative infinity is 1. And the last one, limit as x approaches infinity from f of x is negative 1. Okay. Again, this means nothing. It should not mean anything to you either, please. I'm begging you, please say yes. It doesn't mean anything to me either, please. Now it will make a lot of sense once we organize the information correctly. So I see 0. 0 from either side is infinity, okay? Which means this, it doesn't touch, which means x equals 0 is a VA. So this is done. Then I see something at 3. Okay, fine. Let's move at 3. At 3 from the left is negative infinity. At 3 from the right is positive infinity. So x equals 3 appears to be a VA as well. Then it says the limit of f of x as x approaches negative infinity is 1. Y equals 1, horizontal asymptote here. Limit as x approaches infinity is negative 1, which means y equals negative 1, a horizontal asymptote here. Now it makes sense. This makes no sense to me. Now everything is very clear, 100% clear. So then I can graph. Y equals 1. X equals 0. X equals 3. This is not the graph. The asymptotes have to be graphed first. And now I will graph the function. Oh. Ready. 1 to infinity on the left-hand side of the vertical asymptote. No biggie. From positive infinity to negative infinity on the left-hand side of this asymptote. It has to approach asymptotically. Closer and closer, closer and closer. On the other side of the vertical asymptote, it's coming from positive infinity going to negative 1. No biggie. Again, from 1 to infinity. From infinity to negative infinity. From positive infinity to negative 1. This is my example. You can get fancy and do other things and put another vertical asymptote here if you want or whatever. But this is the simplest possibility. So this was 7. Let's see why I picked 49, and then we'll go to more limits. I have no idea why I picked 40. Any questions on this problem? $49. Why did I pick 49? Oh, yeah. So it's those limits. We don't have to do 49. We can do anything else. Find the horizontal and vertical asymptotes. That's why I picked 49. So for 49, we have y equals 2x squared plus x minus 1 over x squared plus x minus 2. We're asked to determine